At AP Review, this is 2005, Form B, AB Free Response 3. So a thing to note is that in 2005, Free Response 3 was still a calculator problem, which is a thing that is easy to forget sometimes because nowadays it's only 1 and 2, but just worth noting it's a calculator problem. So the very first thing that I would probably do, given that this is a calculator problem, and you don't have to, but the very first thing I would probably do is I would probably put v of t in as my y1, right? So my y1 would be natural log of x squared minus 3x plus 3, right? And you don't have to do that, but that's what I'm going to do first. All right, cool. So now let's keep moving forward. So part A, find the acceleration of the particle at t equals 4. So this is actually one you could do pretty easily by hand, but there's not really an incentive to do it. So a of 4 is the same as v prime of 4, which you can make your calculator do, right? So you can make your calculator do v prime of 4, right? If you wanted to make your calculator do it, you would do math 8, which is n derived, y1 with respect to x at 4, right? So if you did that, you're going to get a decimal, and the decimal's not wrong, right? So if you do that, you're going to get this decimal. And that decimal's not wrong, but that decimal is a 5/7. If you do it by hand, it becomes pretty clear. So it's a 0.714 approximately, right? But if you math bracket, it's actually a 5/7. And if you had done it by hand, you'd also be able to see that it's a 5/7. Because if you did the derivative by hand, your v prime of t would have been a 2t minus 3 over a t squared minus 3t plus 3, which means that your v prime of 4 would definitely have come out to be a 5/7. So either way you did it is fine. Again, because it's a calculator section, there's not a huge incentive to do it by hand, right? If it's a calculator section, it's way more advantageous to just have your calculator do the heavy lifting. You should still communicate that you understand that a of 4 is v prime of 4. Cool. Part B. Find all times t in the open interval from 0 to 5, at which the particle changes direction, during which time intervals from 0 to 5 is the particle traveling to the left. Okay, cool. So the thing is, again, that it's a calculator problem, right? So let's translate what they're asking in part B, right? Part B asks you for two things. First thing they ask you for is times when the particle changes direction, right? And then the second question they ask you is going to be a logical result of that, which is the intervals when you're moving left, right? When the particle's moving left. So let's talk about what changes direction means first, right? So this is what they're asking, and we need a little flowchart to talk about what that means. So changes direction, right? And we'll just kind of erase that note about y1. To change direction means, by definition, that velocity changes sign, right? But what that means for me in this problem, specific problem that I can see with my eyes, right? So what I can see with my eyes is that the graph, right? The graph that I have in my calculator crosses the x-axis, right? Because if velocity is the y on my given graph, I'm looking for when the graph crosses the x-axis. So I can find those values by doing second calc 0. Now, what I haven't done yet, but I'd suggest that you do, is you're looking at times from 0 to 5. And remember that in this situation, your time is x because I'm still in function mode. So for my window, I'm going to change my x window from 0 to 5. And my y window was something crazy before because, sorry, my bad. My y window was something crazy because I was doing some other problem and whatever. So I'll just change my y back to the standard -10 to 10. All right, so when I hit graph, I want to know where this thing crosses the x-axis. So I can see that it crosses twice here, like pretty quickly, 1, 2. And then that seems to be it. So I'm going to second calc 0, right? And I like to start with the one farthest to the left and then work my way to the right as I go. That's mostly my easy way to make sure I don't miss something. So I go and make sure I get to the left of that 0, which in this case is above the axis, so my y is positive. Then I go to the right of that 0, which means I cross into the negative y values, and then I hit enter. So the very first value is x equals 1. Well, that was nice and friendly. Okay, so the first answer is when when t is 1, right? My calculator said x is 1, but t is 1 is my first answer, right? So the first answer is t is 1. And then the other one may not turn out quite so nice. We'll find out. Maybe it will. So I go ahead and graph, and I do second calc 0. And I'm going to grow a little bit over. I don't want to cross back into the positive because I want to stay to the left of that 0, right? I hit enter, and then I scroll across the axis to hit the right 0. I need to make sure I get across, hit enter, and then I guess. And the other t value is t equals 2. Well, that was nice and convenient. So those are ones that I could have found by myself, which is nice. So you could have found them by hand, right? And we can talk about how to find them by hand in a sec. And that's fine. If you want to find them by hand, you can. We'll do that in a sec. So the answer to the first question is that the particle changes direction. Well, let me be clear. V changes sign. In both of these situations, they weren't double roots. So I didn't actually spend the time to show you that, but V is positive before it crosses at 1, and then V is negative, and then V goes back to positive. Okay, so that's the answer to when this thing changes directions. Now we talk about moving left. Well, moving left, by definition, means that V is less than 0, right? So what that means from what, so this is the definition, right? What that means for what I can see with my eyes is that the graph is below the x-axis. Graph is below the x-axis, right? And that happened between these two, so that would be from 1 to 2, or if you want to write it as 1 to 2, that's just fine, right? Either way you write it. So the graph is below the x-axis, and that's the connection I need to make. Now, I did say that if you had wanted to do this by hand, you definitely could do it by hand, right? And I just want to point out that that is an option. Had you chosen to do this by hand, right, the trick would have been to set your velocity equal to 0 and solve and then make a sign chart. So if you had chosen to do this by hand, again, it's not recommended in this situation because sometimes the numbers come out disgusting and there's a reason you have a calculator. If you had to do this by hand, you would set this guy equal to 0, you'd exponentiate both sides, and you'd get t squared minus 3t plus 3 is a 1, so you'd get t squared minus 3t plus 2 is a 0, and that's how you get the two nice t's that you got, right? And so you'd get t is 1 and t is 2, right? And if you made a sign chart for this guy, what you would find if you make a sign chart for this is that your graph essentially does exactly what we expect, 1 and 2, and that's sort of the gist, right? So like if we find our value, what we would find is we'd find a positive velocity here and then a negative velocity here to positive velocity here, right? So if we had made a sign chart for our v of t. Cool. Anywho, so, and you can actually figure that out by making a sign chart for this as well. But yeah, so cool. Part, that was B, right? Part C, find the position of the particle at 2. Okay, so for part C, they want x of 2, right? So they want our position x of 2. So the trick here is that when we want to find our position, right, this is a first fundamental theorem of calculus question, right? So first fundamental theorem of calculus says that if you integrate f prime of, let's say, x from a to b, you get f of b minus f of a, right? Well, in this situation, we're integrating x prime because the important thing to recognize is that v of t is the same as x prime of t, the position prime. So if we were to integrate x prime of t with respect to t from, let's say, 0 to 2, and the reason I pick 0 and 2 is I know x of 0 and I want x of 2, I would get x of 2, which is the thing that I totally want, minus x of 0, which is a thing that I know. So that's the trick. That's that first fundamental theorem of calculus question. So in order to find x of 2, I'm going to integrate my x prime of t with respect to t from 0 to 2 and get x of 2, again, that's the thing I want, minus x of 0, which I totally know because they gave me x of 0 is an 8. So this I can make my calculator do, right? So what I'm going to do in my calculator is I'm going to integrate v of t, because that's what x prime of t is. Oh, sorry, that was with respect to t. Mea culpa. With respect to t from 0 to 2. And I'm going to add that x of 0 over. So I'm going to put x of 0 plus that quantity, and that'll give me my x of 2. So I'm going to type into my calculator 8 plus function integrate y1 with respect to x from 0 to 2. And again, that calculator notation isn't what they need to see on the AP. They need to see this on the AP, but that's what you're going to have to type in your calculator to get x of 2. And when you do that, you end up getting that this is an 8.368 or 369, depending on how you round or truncate, for your x of 2. Cool. Part D. Find the average speed of the particle over the interval from 0 to 2. So this is one where you really do need the calculator to do it. So the trick is that if you're asked to find the average of a function, any function, right? So if you're asked to find the average of some function, let's say f of x, right? The way you find that, so on some interval from a to b, right, is by doing 1 over b minus a times the integral from a to b of that function, right? So here's the tricky part of this. In part D, you were asked to find the average of the speed. Well, that means that you need to know what speed is. And in this case, the speed is the absolute value of velocity. That's the definition of speed. So what you need is the integral from 0 to 2 of the absolute value of v of t dt over times a 1 over 2 minus 0. My bad. So this is the setup you need to have. And then all the AP cares, so the AP wants this, and they want the answer you get by typing it in your calculator. What they don't care about is the actual work behind it. So I'm going to put a 0.5 in front of function integrate, which is math 9. I'm going to do abs, right? y1 with respect to x from 0 to 2. And that is what's going to get me this answer, right? So again, just to show you how we type that in, right? So I'd get a 0.5, right? Math 9. And then I'm going to go to math. I'm going to go over to numbers, and I'm going to pick abs, okay? Of my vars, go over to y vars, pick y1, right? Close the absolute value, comma, with respect to x, from 0 to 4. I'm going to double check that that's right. Cool. And then I hit enter, and it does some mathing for me. And there's my answer. So the answer the AP would want is either 0.370 or 0.371. Either is fine. Again, the AP wants this, but you have to know how to do this to get there, okay?